Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight is one of our students who I'll let say hi and introduce himself.
Hi everyone, my name is Eli. I'm a physics and astronomy student at UMD.
So, tonight we thought it would be really fun to kind of take a look at the past year in astronomy and talk about some of the highlights, some of the really cool happenings from the past year, because there was actually a lot. I had to really pick and choose stuff to talk about tonight. There was quite a few things. So before we get into it, as always, if you have any questions throughout the show tonight, feel free to leave them down in the comments. Eli will be keeping an eye on that. Will let me know when questions come up. If we don't get to them right away, we will take time to answer any questions we missed at the end of the show as well. All right, and with that, let me get everything set up. Pin myself. Do that. All right. There we go. We should be all set. So yeah, like I said, tonight we're looking at kind of the best of 2021 in astronomy, and I've kind of broken this up into two segments. So we're going to first look at kind of scientific discoveries in 2021, and then we're going to take a look at spacecraft and missions and things like that. Again, I do not have every single thing that happened in the past year because there was a lot. So if there's anything that you thought was really cool that I don't end up talking about, leave it down in the comments. I'd love to know if there's something that I didn't cover tonight that you thought was kind of like a best of. So we're going to start with in our solar system with the planet Jupiter, because last year a new moon of Jupiter was discovered. And finding a moon around Jupiter isn't unheard of. We know that it has lots of moons. Before this, the count was at 79. Now Jupiter's at 80 moons. But the really cool thing about this discovery was it was actually discovered by an amateur astronomer. They were the ones who saw the kind of evidence of a new moon around Jupiter, saw it in the images, brought this up to astronomers who then confirmed the finding. So an amateur astronomer was actually responsible for finding the 80th moon around Jupiter, which I just think is really cool. Another really cool thing that happened was more imaging that came out of the Event Horizons telescope. So you may remember a couple years ago, we got the first ever picture of a black hole, and that was of the supermassive black hole at the center of M87. That picture was taken by the Event Horizon telescope. And so last year, they published a brand new image, which you're seeing, the big image here is from the Event Horizon telescope. And this is actually the most detailed and close-up image of the jet coming out of a black hole that we have taken to date. So this is from the supermassive black hole at the center of the Centaurus A galaxy. And you can see on the bottom left is the full picture of the galaxy. We know that there is a supermassive black hole at the center of the galaxy. That black hole has about 55 million suns worth of mass. And you can see just in the images that we have these jets being pushed out by the black hole. So what we're seeing here is a very close-up image of the jet that is right next to the black hole itself. This is letting us see closer to the black hole than we've ever been able to see before, and will help us better understand the mechanism behind creating these jets that a lot of black holes do create. So that's very cool what they're doing. All right. Speaking of black holes, another discovery with black holes or a discovery with black holes that was made last year was actually the closest black hole to Earth was discovered. Now, I know that phrasing that name can be a little sensationalized. This is still pretty far away from us. It's 1,500 light years away. So it would take light 1,500 years to get there, us much, much longer than that. So still very far away, but it's the closest that we have found to the Earth, which is pretty cool. It's also a unusual black hole in that it is very small. It's about 3 solar masses in mass, which is a pretty much one of the smaller end of a black hole that you can get. And these are, of course, difficult to find because they are so small. They don't have very strong gravitational influence on their surroundings, which is how we detect a black hole. So not only is it closest, it's a very small one, and it kind of helps us better understand how black holes form and how you can get to these much bigger ones that we do find. This is, and I have to make sure I say this, given that the last image was a real image of the jet from a black hole. This is an artist's interpretation of what the system would look like. The black hole actually has a companion red giant star, and we can tell from the light coming from the star that the star is kind of warped. Its shape is not all nice and spherical because the gravity from its companion black star is warping the shape of the star, giving it this very weird, elongated, oblong kind of look to it. All right, and then the last of the scientific discoveries that I wanted to kind of highlight in our show tonight is probably my personal favorite, and that is the first evidence we have of an exoplanet in another galaxy. Now, we have found lots of planets around other stars in our own galaxy. I think we're up to, I want to say, over 3,000 confirmed exoplanets in our own galaxy. But those are all confined to within a few thousand light years of us because those are easier to monitor. The stars, it's easier to notice when changes happen, and it's just easier to find them closer to us. But last year, researchers actually found evidence of a exoplanet orbiting around an X-ray source in the Whirlpool galaxy, which sits about 28 million light years away from us. This candidate exoplanet, it is still a candidate. We don't have full confirmation yet, but this candidate is expected to be about the size of Saturn, and it's thought to orbit either a neutron star or a black hole, something that gives off X-ray light, and is estimated to be about twice as far away from its thing it's orbiting than Saturn is from our sun. So it sits 2 times further away than Saturn does from our sun. So there's a lot of really cool things here. One, it was a different technique used to find this candidate exoplanet using X-ray light, which is not something we've really done before. Two, possible exoplanet seen in another galaxy, which is awesome. And three, a planet that could be orbiting a black hole, which isn't, impossible. Of course, it's completely possible for that to happen, but to actually see that we have a candidate planet around a black hole, like that just makes my science fiction brain like very excited about what it could possibly be like. Okay, so moving on from the more scientific discoveries, I want to take a look at some of the big spacecraft and space mission kind of achievements that happened over the past year. And I think this is where the bulk of what most people know about and are kind of excited about what happened in 2021. So first, we had 2 new missions announced by NASA with plans to send these 2 missions to Venus. Now, we have not sent a dedicated mission to Venus since 1989. So we have not really been neglecting it, but it hasn't been what people have been most excited about studying. That's pretty much been Mars, at least of, planets in our solar system and planets closer to us. But with the possible source of phosphine in the atmosphere, which has since we found out that that probably wasn't actually there, but it just kind of reignited this desire to study the planet more. So NASA has announced two new missions that they hope to launch by 2030. One of them is Da Vinci, which is short for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus. That is actually going to land on Venus and give us information as it falls through the atmosphere and information from the surface of the planet. And then the second mission is Veritas, which is Venus Emissivity Radio Science INSAR Topography and Spectroscopy, which is going to be an orbiter. So it's going to orbit Venus and take images and measurements from orbit. And of course, the idea is we want to better understand what's going on in this planet, since we know that Venus has suffered a runaway greenhouse effect, which is why it is the hottest planet in the solar system, despite not being the closest planet to the sun. But we also know that in its past, it was more Earth-like. So better understanding exactly what happened to trigger that change in Venus from being Earth-like to the, you know, hellscape that it is today. I'm sorry, that's kind of the best descriptor of it, is something we're very interested in, especially given the rise in global temperatures that we are seeing here on Earth. We want to better understand this process and hopefully learn how we can prevent Earth from becoming Venus 2.0. Another really cool event we had was from the Parker Solar Probe. Now, the Parker Solar Probe has been in orbit around the sun for, I believe, 2 or 3 years now. But last year it made its closest approach to the sun, pretty much touching the outer edges, the outer atmosphere of the sun, which was just really cool to see. It's the closest we've ever gotten a spacecraft. It ended up being about 8.1 million miles from the surface. I put that in quotes because there's no solid surface. Passing through the very outer atmosphere and giving us information on what that's like, and helping us just learn more about the sun. All right, next one is probably not going to be a surprise to anyone who has been watching our shows for the past year or even 2 years. You know I got to talk about Perseverance and Ingenuity. This was a huge event for 2021. So first off, we of course had the landing of Perseverance on Mars.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses.
I don't want to watch the entire video, so let me just,
Give the way
um,
better look at the
we have
planet.
shown this video before, and I'm gonna mute it real quick. So we had Perseverance land on Mars in a very crazy way, having not only just the parachute, but it had a kind of hovering sky crane that lowered the rover down onto the surface. And this has been attempted once before with Curiosity, successfully done. So this was our second attempt landing a rover this way. But what I really thought was cool about Perseverance's landing is what you're seeing here, actual video from the rover as it was doing its descent. So you can actually see what it looked like for this rover to descend and land on the surface of Mars. And I know we have showed this video before. I have watched it, I don't know how many times. I love it. And I will fast forward just a little bit because I don't want to spend all of our time here. But you can see as it gets closer, it kind of coming down from that hovering sky crane and landing safely there on the surface of Mars. So this was the next kind of big step in our rover exploration of Mars. This was a very big rover, very much like Curiosity, but has even more going on, even more science to do, and even more I love all the excited. I mean, it's just awesome. Okay. One of the big things that Perseverance has that Curiosity doesn't is it's actually taking samples from rocks that it finds that are interesting on Mars and kind of packaging them up. And the idea is that NASA is working on a future mission to go and collect those samples and bring them back to Earth. So it's the first step in us actually packaging up samples from Mars and bringing them to Earth, which is pretty cool. And then, of course, the other really big thing with Perseverance is it carried with it Ingenuity, which is a little helicopter. And this was the first attempt that we have ever made at controlled flight on another world. And theoretically, it was possible. Mars has an atmosphere. It's thin, but it has one. And this test of Ingenuity proved that you can have powered controlled space flight on the planet. Since its first flight, we have had 18 successful flights of Ingenuity. It is definitely performing way better than anyone had ever hoped, and is just providing a lot more to the Perseverance mission because it's able to scout out areas for Percy to go and explore. It's also able to get close-up imaging of places that Perseverance can't get to. So it's just really opened a brand new method of exploring the surface of worlds, at least those that have an atmosphere that we can fly in. All right, I think I have like two more. Next up is a pretty big SpaceX achievement. They had a lot going on in the last year. Of course, they had several launches taking astronauts to the International Space Station. They, of course, also had the all-civilian Inspiration launch that happened. But the really big one, at least that sticks out to me, is this test of Starship SN15. So Starship is supposed to be the launch vehicle that NASA is hoping to use to take us back to the moon for the Artemis mission. And what's unique about Starship, unlike the other rockets that we have used to go to the moon, is it's supposed to be reusable, which is kind of SpaceX's thing. They create a lot of capsules and a lot of rockets and things that can land safely back on Earth after they're done and then can be reused, which is huge towards kind of bringing down the cost of space travel. Well, they, prior to SN15, had tested Starship out, I believe it was 4 times prior to this. And they'd had good flights, but they'd never been able to successfully land Starship back down. They either weren't able to land it and it crashed, or they landed it and then it immediately exploded upon landing. So what was special about SN15 was this is the first test that they did where they were able to successfully launch and land the Starship. And it's kind of crazy to watch. So this is a kind of condensed video of what happened. So there's the successful launch, flying through. It does some maneuvers while it's in flight to kind of test different capabilities. And then here it comes back down. I swear this looks like CGI, but I know it's real. I watched it live, but it's still just crazy watching. And there it goes, safely landing back down. So huge achievement for SpaceX in getting that to finally successfully land and bringing us one step closer to getting the Artemis mission off the Earth and getting astronauts back to the moon. And of course, there's no way that I could talk achievements of 2021 and not talk about James Webb. I have waxed poetic on this for the past few shows, but the James Webb Space Telescope has been, from what I read, 25 years in the making, and finally successfully launched on Christmas Day. and since then has been successfully unfolding itself, which is necessary because to send such a big telescope into space, you had to kind of origami it up and fold it up to fit inside the rocket, and then when it got into space, it had to unfold itself, and that's been the most terrifying part about this launch is this going to unfold correctly? And it has. Everything has unfolded. The primary mirror is now unfolded. They're going underway to move the tiny little mirror segments to get everything all up and going. The last kind of next big hurdle is in 2 weeks, getting it into its final orbit spots. But fingers crossed, knock on wood, throw salt over your shoulder, whatever you want to do, things are going well. And this is going to usher in a brand new age in astronomy, and I am ecstatic for it. All right, and then the very last thing I wanted to touch on, bringing it back home, we at the planetarium, of course, had a lot of things happening behind the scenes since we have been closed for most of 2021. But the kind of one of the major things that happened for us was the launch of our Allsky Camera, situated up at the Chickawauk Museum and Nature Center. And so I just wanted to highlight this camera for anyone who hasn't had a chance to see it. I actually have the public website for the camera listed in the video description. But it gives us these gorgeous views of these super dark skies up in northern Minnesota, like very, very northern near the Boundary Waters. And of course, I had to pull this video of the stunning aurora that we captured back at the beginning of November, because what better way to round out a show about the awesomeness of 2021 than showing this amazing video, which I love, and again, have also watched probably way too many times, but it is, I love it. And what's really great about this is kind of just the beginning. As the sun kind of picks up in activity as it heads towards solar maximum, where it has all of that activity, has lots of flares and activity and things like that, we will be seeing displays like this much more often. So definitely keep an eye on that. We have a Facebook page that you can go check out. Again, I have the website linked below. Yeah, definitely check it out and keep an eye because we're gonna get some fantastic stuff from it over the next few years.
So as we're rounding off, somebody was asking for details on James Webb. I figured we'd wait until we got to that. But one question that went unaddressed, who was James Webb? James Webb was, I believe, an administrator of NASA in the late 60s to, hold on, let me look. Oh no, so he was the administrator of NASA from 61 to 68. And he was a really big part of the Apollo program.
Yeah.
So that's why they dedicated the telescope to him. Before it was called James Webb, it was called Next Generation Space Telescope.
I think so.
Yes. Yep. Yeah. Next Generation Space Telescope. But then they renamed it to the James Webb in like 2000.
Yeah, sometime.
2002.
Okay, so I know you're asking for lots of details, and I'm going to put a mild hold on that because based off of my excitement over James Webb and wanting to just talk about it so much, I have decided that one of the shows we're doing this month is an Exploring Space Telescopes show. And so we'll take a look at kind of why we need telescopes in space, kind of the prior generations of space telescopes, and then talk in depth about James Webb. So be on the lookout for that. That's happening. I believe it'll be towards the end of the month. That's kind of our next. I don't think Eli even told you about that one yet. But yeah, I want to do it because I want to talk more about James Webb. So we will do an entire show dedicated to space telescopes.
Yeah. I'm excited. There's a book that we use for astrophysics classes And I think there are only 2 editions of it.
Yep.
It's oh shoot, I should probably turn off my background.
It's okay. You could see it.
Oh, you could? Yeah. So
Yeah.
we call it Bob the Big Orange Bible, and there are only 2 editions of it. And I believe the second edition came out when
Hubble, I believe.
no, I don't think it was Hubble. Maybe it was, but we got better data concerning like how many galaxies there are in the universe, and the density of the universe and stuff like that. And there's definitely gonna be a third edition, or a new book or something, because it's gonna.
Yeah, all astronomy textbooks are going to have to be rewritten, which is already a thing that happens. Most astronomy textbooks, you do see new editions every minimum 2 years.
Yeah.
Because there's always new stuff coming out. So the thing with the one that Eli's talking about is it's a lot of fundamentals, which is why it hasn't really changed much. But even James Webb is going to be showing us some brand new stuff.
James Webb is gonna, especially cosmology, I feel like it's gonna really change some stuff for us, because as of now, like when we try to figure stuff out, we have to think about what the early universe was like, and we have to make our best guesstimates on how much stuff there was, how many how early galaxies formed, what the density was very early on, but we're actually gonna know, like,
We're going to see.
Yeah. Oh my
It's
God,
crazy.
it's so awesome. I'm so excited, but I'm not excited because I'm gonna have to buy a new book.
That's okay.
Will we ever be able to see inside of a black hole? If so, what would you conjecture might be in there? No, we won't.
No.
We can't. That's kind of the definition. That's why we call it a black hole. And the unfortunate thing about it is we could send someone into one, but they'll never be able to tell us. So no, we won't ever know what's inside a black hole. And as for what's in there,
So
a lot of light.
Ideally, in the future, we may be able to model what the inside of a black hole is like. The reason we haven't been able to do that before is because things are so weird and extreme inside of a black hole that you basically have to be able to marry gravity and general relativity with quantum mechanics, which are 2 very different ends of the kind of physics spectrum and usually have nothing to do with each other. But under the extreme conditions of a black hole, they do. And we don't quite yet understand how those 2 work together under those conditions. So we have to be able to marry those 2 things together before we can really understand what's going on in there.
If you've seen the movie Interstellar, that is not what's inside a black hole, probably. I'm going to say 99% sure that's not what's in there. One interesting thing that I've talked about with, I don't know who, people in the department, is that inside of a black hole, so all this light that the black hole gobbles up, all that light, as it so there's a thing around a lot of black holes called an accretion disk, and it's this big disk of gas and dust that's moving really fast, and all of the particles and atoms are smacking into each other, and they're creating a lot of heat, and that heat generates high energy radiation like X-rays and stuff. And so like when you go to the doctor, aside, this is also I find funny. When you go to the doctor and they're like, "Oh no, it's completely safe. Don't worry about it." And then they put this like big lead sheet over you, and then they go into a separate room and stuff. I think that's funny. But it's that same kind of light. And so if you were to go into a black hole, you would get absolutely fried from all that light that's in there. So lots of
Fun things.
Yeah, nothing good happens. But there, and what we do know is in there is a singularity, which is
the term we use because we don't understand.
Right. It's
basically
where physics breaks at that point. Can you recommend a book or source for lay people about astronomy?
Ooh,
Oh, yes. I've got one.
Yes.
Um,
I mean, I would look up things by any of the books by Bob King
yeah, for
are
sure.
fantastic, but that's definitely more like naked eye, what you can see up in the sky, and not so much the full realm of astronomy.
Yeah.
What you looking for?
I really here.
Ah, okay. I should have known that's what you were going for.
Yeah, this book is I think very important. Welcome to my room. Cosmos by Carl Sagan. It's like a I mean it basically is that. I mean it's like a novel version of astronomy. It's written as almost like a story. And it tells you just a lot of great stuff. New Moon's Family. We actually have that in the planetarium. Um, uh, that's a good one.
Yeah, during the astronomy day that never happened back in 2020. We were supposed to have a story time with the author of New Moon's Family actually coming in and reading for us. There are still hopes that we will have that happen next time we can do some public astronomy day stuff. But yeah, no, we have it and it's adorable, and I'm very sad that we didn't get her in.
Yeah. Sorry, now I'm just kind of looking through Cosmos. It's such a cool book. It's really good. I would highly recommend it. Also, what's the one by Stephen Hawking? Uh, Shoot, give me a second.
You have Google. Jill, what do you mean by tesseract, yes or no?
I'm assuming, like, are they possible?
Isn't a tesseract a 4D?
It's a 40 cube.
Yeah.
I think there's some like science fiction analogy to like a time space travel machine. I know it from A Wrinkle in Time. They talk about a tesseract.
Oh, they do, yeah.
But yeah, hold on. A Brief History of Time. A Brief History of Time by Stephen Hawking is also very good. That is actually a novel. There's like not many. I don't know if there are any pictures. It's like actually a novel, but it's really good.
So, I mean, back to the tesseract. Um, that's kind of a hard one to answer because, I mean, yes, it's possible, but no, we probably wouldn't be able to perceive it
Yeah.
because we perceive things in three
Three dimensions.
dimensions.
Yeah.
We can't perceive the fourth dimension all at once.
Yeah. You can unfold four-dimensional shapes, like you can visualize them in a 3D space, but the connection doesn't really happen. Like it's not like you can look at the three-dimensional representation and then understand what it is. Also, we don't live in a four-dimension. Well, we don't live in four spatial dimensions. So
Correct. Our four dimensions are three spatial and one time.
I know there's something about it in like space travel. Yeah, A Wrinkle in Time, Science Explained. Here we go.
I feel like I need to reread that book.
Yeah, it's a really good book. They made a movie about it, I think.
They did. I have not seen it.
No, I haven't seen it. Oh, apparently at the end of Interstellar when shoot, what's his name?
I haven't seen Interstellar.
I forget his name. Apparently the thing at the end is a tesseract. Okay, so I want to talk about, sorry, I'm going to make this run long, but I want to talk about something that I think is really interesting. The person asking about the tesseract is talking about folding space, which is like, I suppose I don't want to see the movie because I have the pictures in my mind. Yeah, I understand that. But they're talking about folding space. So there's as a method of space travel, I think. I'm going to turn on my background because I'm feeling my plant doesn't look very healthy and it's making me feel kind of Embarrassed as a plant owner. There's this thing called the Alcubierre drive. It's completely a work of science fiction at this point, but it's the same idea, but it's kind of like made practical. So, or like with physics, and the idea is like if you concentrate enough energy at a point, you will warp the space in front of the energy, and then you could just like it is like the classical analogy of like, you know, you fold a piece of paper and you move from point A to point B. It's like that. It's totally science fiction, but it's kind of the same idea. I'm sure there are videos about it on YouTube. Here, I'm gonna there. Check that out. It's kind of cool. It's kind of, I think it's like kind of a realistic tesseract type idea, but it's really cool. So
I have to look into. I haven't heard of that one.
it's cool. It's cool. I mean, it seems like kind of corroborated up to a certain point.
Mhm.
It's pretty cool.
Well, and I would say, like, if we're going to do any sort of faster than light travel, it's not going to be by actually getting up to speeds
No.
of the speed of light. It's going to be by manipulating space-time itself.
Mm-hmm. Yeah.
Yeah.
But yeah, check that out. It's kind of a like a. So who knows what will be the physics then of the black hole?
So we don't know. We know what happens up to the event horizon, and we know that within that, the speed needed to escape the gravity is faster than the speed of light, which is why nothing can escape a black hole. We just don't know what the actual conditions are like inside of the black hole itself.
Yeah.
So we can understand everything that's going on outside of it. We can understand what's going on to form it. And up to that event horizon, it's just we can't say this is what the conditions are like inside of a black hole because we don't know yet.
The only things that are for certain are that once you're in, you're going towards the center. And I've heard an interesting analogy that says like, so like right now, like I'm sitting here and I'm not moving. I mean, Earth is moving, but I'm not moving. But I am moving towards tomorrow. Like I can't stop myself from going to tomorrow. Like there's like I can't go backwards. And I've heard the analogy made. I don't know how legit it is, but like once you're inside a black hole, it kind of flips. So like time is kind of done. Like time isn't really a thing anymore. But you are going towards the center of the black hole. There's nothing you can do. Like it's like I'm going to tomorrow right now. You're going there. And so that's kind of the only thing that's certain.
Yeah.
Also spaghettification.
Real scientific term. Love it.
Yeah.
Yeah. And if you haven't seen it already, we did do, I think, one of our first exploration shows we did.
I think it was the second one.
Was it the second? Yeah, because I think the first was Mars, because that was right after Perseverance. So if you go back through the videos, either on the videos tab of our Facebook page or over on our YouTube channel, we did a exploring black holes show, and it kind of goes into some of the basics and how they form and that sort of stuff. So if you're interested in a little bit more in depth, you can go take a look at that. Yeah. All right, well, it looks like things are starting to wrap up somewhat. So I will take one last call for any last questions that anyone has. While we give that a minute to see if more questions come in, let me tell you what's coming up over the next week. So on Saturday, we're going to be doing Ask an Astronomer, which is honestly a lot like what it's been like the past 5 minutes. We will be here to kind of just answer your questions. I say we, but it might just be Eli. We'll see.
Yeah.
So be nice to Eli if it is just him. But we'll be here just kind of a fun hangout for a little while, answer your questions, probably give some updates on James Webb. I don't know. We'll see what happens.
Yeah.
Then next Wednesday, I wanted to do our exoplanet show, since one of the things that James Webb is going to be able to do is give us more information on exoplanets. And it's been a while since we've done a show on exoplanets and kind of what's out there. So I want to do that next week. And then next Saturday, it's also been a while since we've gone on a tour of our solar system, so I figure we'll talk other planets around other stars, and then on Saturday we'll come back to our home star and take a look at our planets up close. So that's kind of the next week of shows that we have scheduled.
Yeah, so we got just a couple more questions. Do you need volunteers for Family Space Day or Astronomy Day, if it's able to happen?
Don't know yet.
Don't know yet.
It depends on what scale we end up going with.
Yeah.
Whether we do something smaller like we did last year, or if we do try for a more full scale day. That's very heavily going to depend on how everything is going and how everyone is doing. But if we do end up needing any help or volunteers, we will definitely put a call out to our social media.
And then, did you celebrate Hawking's birthday? I knew that it was Hawking's birthday. Interestingly enough, Hawking's birthday is also the day that Galileo died. So
that's right.
Kind of a big day. Another question: what is the speed with which you impact the event horizon when you fall into a black hole? I suppose it depends.
Yeah, I don't know.
Yeah, I mean, I guess it depends on a lot of factors.
And you don't really impact anything.
Yeah.
Like we call this the event horizon, but there's not like a wall or anything. It's just a point in space that once you've passed it, there is no coming back.
Yeah.
Yeah.
It's not like a wall. It is the escape velocity. Is that true?
I don't think so. I have to look into it. I have to look into it. I think technically so the way escape velocity is derived is it's what it would take to go to infinity from the object.
Yep.
So the vice versa could be true.
So if your velocity was... Well, now I want to do this. Give me a second.
But no, it depends on whatever you're starting.
Yeah, because you could be moving, 5 kilometers per hour and then start moving towards the black hole.
I don't think it's necessarily the speed of light.
I don't think it is. Hold on, let me look this up. Yeah, it depends on how fast you're moving.
But anyway, that's going a little bit more in depth into the math and physics than we normally try and do. Yeah. All right, so I think we'll wrap up there. Thank you everyone so much for joining us. We hope to see you again. Have a wonderful rest of your Wednesday, and we'll see you next time. Bye, everyone.